Hello and welcome to CSIT 165, Module 15. In this module, we'll be going over how to make data come to life. One of the most powerful aspects to working with R for data analysis is the many ways we can communicate results. We describe ways of making visualizations interactive using Plotly, Arboca, and Leaflet. These interactive visualizations can be made to use to construct HTML pages so that we can have interactive documentation. These HTML pages are great for making slides or documents. For this chapter, we'll have a few things that we're required to do. The first task will be reading. The reading will consist of both Programming Skills for Data Science, Chapter 17, and R for Everyone, Chapter 28.5.2. In Programming Skills for Data Science, Chapter 17, we'll be going over interactive visualization in R. Adding interactivity to a visualization provides an additional mechanism through which data can be presented in an engaging, efficient, and communicative way. Interactions can allow users effectively explore large data sets by panning and zooming through plots, or by hovering over specific plot geometry to gain additional details on demand. While ggplot2 is the definitive leading package for making static plots in R, there's not a comparably popular package for creating interactive visualizations. Thus, this chapter briefly introduces 3 different packages for building each visualization. Instead of offering an in-depth description as with ggplot2, this chapter provides a high-level tour of these packages. The first 2 packages, Plotly and Boca, are able to add basic interactions to the plots you might make with ggplot2, while the third package, Leaflet, is used to create interactive map visualizations. Picking among these and other packages depends on the type of visualizations you want your visualization to provide, the ease of use, the clarity of the package documentation, and your aesthetic preferences. And because these open source projects are constantly evolving, you will need to reference their documentation to make the best use of these packages. Indeed, exploring these packages further is great practice in learning to use new R packages. For this module, we will have a graded discussion 15. Graded discussion 15 is similar to other graded discussions in that you should respond to each prompt with a 1 paragraph of 3 to 5 sentences. These responses should be submitted by Wednesday. After submitting your responses by Wednesday, please respond to 2 of your peers' posts. These responses to your peers' posts should be submitted by Sunday. The rubric for this consists of 20 points, that consists of 3 well-written responses and 2 well-written replies. For the first question of the prompt, please discuss some of the advantages and disadvantages to using Plotly versus Arboca for constructing interactive visualizations. For number 2, how does creating map visualizations differ using Leaflet as compared to building maps with ggplot2, aside from the interactivity? Specifically, how would we go about using different maps in either program? Try using both and describe your findings. For number 3, describe scenarios that you may use interactive visualizations in the workforce. As well, for this module, we will be introducing the Group Project 2. Group Project 2 will be the final project in this course and will be a summation of everything you've learned thus far, as well as some new things with interactivity. For this group project, you will be submitting a team contract as well as the same way that you submitted a team contract for the group project 1. For the team contract, the contract is due Tuesday, May 12th by 9 p.m. It's due now at 9 p.m. because I will be grading these as well as submitting to you your teams that you'll be working with on the project by 12 a.m. that same day. The contract is worth 5% of your grade for Project 2. Please turn in the team contract as it is a very easy way to earn 5 additional points for the project. For the instructions, please state who your partner will be for the group project. If you do not submit a response to the team contract, then a partner will be chosen for you based on total grades. Failure to submit a response will result in a loss of 5% of your total project grade. Each group will receive email confirmation of the group members. The project will be made available after Tuesday, May 12th at 11:59 p.m. as an assurance that it is began as a group. It is strongly recommended to finish this week's reading before this time so that you have more time to finish the group project. Now, for the group project itself, I will be going through a little a little vignette of how it's going to work. The project 2 is due Thursday, May 21st by 11:59 p.m. The rubric for this is consistent with Group Project 1. The team contract is worth 5 points, the team synopsis is worth 5 points, the write-up is worth 20 points, and the solutions that you provide to the objectives are worth 70 points for a total of 100 points. Please read everything very carefully, as the group project is very specific, and to earn full points, you will need to pay attention to the specificities described in the prompt and address them accordingly. For the documentation, each project should be rendered as an HTML document using R Markdown. This is very important. We will be rendering this as an HTML document, whereas all the other projects and laboratories were rendered as a PDF document. To render it as an HTML document, please just include HTML document instead of PDF document in the YAML header of the R Markdown document. Each project report must contain the following. Headers should be used to organize the documents by question or objectives. All the responses should be completed outside of code chunks. That is, subjective responses should be completed outside of code chunks. The response length for these subjective questions should be 3 sentences at least. They should be meaningful and independently contribute to the question prompt. What I mean by independently contribute to the question prompt is that each question should not be redundant, and each question should add a new contribution of meaning to what the question is asking. We don't want 3 sentences differently describing the same exact thing. The source code is required for all of the code that you use to produce visualizations or analysis inside of the class. Comment lines should also be provided to provide meaningful explanations of the logic of the program. All code output is required, and for this project, we want to include a table of contents. This is very important, and we have not included a table of contents in the past, but seeing as though now that we're using an HTML document, the table of contents should be clickable and bring us to our points. As you can see here, I click on documentation, brings me there. Now as we go to collaboration, it brings me to the collaboration section. As far as collaboration is concerned, students will officially elect their collaborators by submitting a team contract as described by Tuesday, May 12th by 9 p.m. Students who submit as team contract but are not in agreement with the proposed collaborator will be paired with a student in a similar predicament. Students who do not submit a team contract will be paired with other students who did not submit a team contract. This project requires students to use GitHub for project control when collaborating with others. Collaborating with GitHub is explained in Programming Skills for Data Science, Chapters 20. I suggest collaborating with a centralized workflow, Chapter 20.3, because it is easier to push and pull for users that did not author the repository. One project member per group must create a new repository on GitHub. Initialize this repository with a README file that lists each member of the group. If your group decides to collaborate using a centralized workflow, recommended, then the project member that created that repository must declare their partners as collaborators in GitHub. Each project member will clone this repository into their machine using RStudio. In RStudio, create a project from version control with GitHub using the HTTP address of the repository created by project member. Please provide a hypertext link to the GitHub repository used for collaborating on this project. To receive full credit for the project solution, please provide a hyperlink text to the GitHub repository used for collaboration and print a Git log at the end of the document in its own self-titled section. To print a Git log, create a bash code chunk similar to R code chunk, but is bash instead of R. Copy the code below and paste it into your code chunk to print a custom Git log displaying subject, author, date, and body of each commit made to that repository. You can see an example here for this bash code. The publicly available GitHub with the README file and GitLog will be used to quantify collaboration as well as test ability to use GitHub in a manner described in programming skills for data science, knowing when to commit, how to write a message with a meaningful subject and body. The data for this project will be the 2019 novel coronavirus COVID-19 data repository by Johns Hopkins University. For the final group project, we will use all of the data sets provided under this GitHub account. That is global confirmed, recovered, and deaths, as well as US confirmed and deaths. Data for the 2019 novel coronavirus is operated by Johns Hopkins University Center for Systems Science and Engineering. Data includes daily time series CSV summary tables, including confirmations and deaths. Lat and long refer to coordinates references for the user. Data fields are stored in month, day, year format. For the background, the Global Health Initiative has recently employed a new data science response team, CSIT 165, that uses data science to characterize pandemic diseases. CSIT 165 disseminates data-driven analysis to global and local decision makers. CSIT 165 is a conglomerate comprised of two fabricated entities, World Health Organization, WHO, and U.S. Pandemic Response Team, USPRT. You and your partner's role is to play a data scientist from one of these two entities. Depending on your assignment, you will provide code in R Markdown necessary to download specific datasets. See project objectives below. If you're assigned a WHO, then you're responsible for writing code necessary to download the global datasets. And if you're assigned USPRT, then you're responsible for providing code necessary to download the US datasets. Your role is assigned when you receive your partner confirmation below. Outside of providing code to download and provide these datasets, the way that you assign each other to do specific objectives is completely up to you. It is, however, recommended that you are able to do all or accomplish all the objectives yourselves, given the opportunity that one of your team members is unable to fulfill their aspect of the project. Everybody is responsible for turning in each objective, regardless of what their project member did. For the project objectives, this project will encompass many of the lessons we have learned throughout the course, including interactive visualizations. As such, we will be rendering the project as an HTML file. Our Markdown files must be written such that each time you render the document, it will download the necessary data sets for analysis. Please render the R Markdown file that day is due before submission as to reflect the most recent data sets. With this added functionality, your code must be able to analyze the data sets regardless of the data you render your document. This is very important. Unlike other projects in the past, you will have the ability to solve these problems using any method you choose. Be careful, however, with the methods you use, as you will be graded on the appropriateness of your solution and how well you execute your desired algorithm. If there appears to be a logic fail in how you executed your code, you will be marginally penalized. Do not be intimidated, though. This is an opportunity to really showcase your newfound skills in data science with R. For the first objective, we want to go through the global trajectory of COVID-19, and for this data set, we want to create a plot very similar to the one that I created here. That is, we want to have a legend with confirmed, recovered, and deaths. We want to customize this legend label, have custom titles, custom access labels, and also custom tick marks. For the second objective, we want to create a global map with those same global confirmed, recovered, and deaths data sets. This map should be interactive. That is, we should be able to zoom in and zoom out on all of the different data points visualized from our data sets. As well, we want to be able to interactively include certain data sets. Here I have confirmed, now I have recovered, now I have deaths. For each of these things, though, however, we want to include custom hover and clicking labels. That is, when we hover over it, we can see that it will say the country. But we also see that it says the province. When the province is available, the hover should reflect what province it is. And when that province is not available, that is, it's an NA value in the data sets, we want it to show the country itself. And here for US, this was not included as a province, and so we reflect it as the country itself. Mexico is a country, Guatemala, El Salvador, etc. When we click on these labels, we want to have custom pop-up labels depending on what data set we're clicking. For confirmed, when we click on it, it should say confirmed and then the amount of people that are confirmed in that data set. When we go on to recovered, however, it should say the same thing. However, it should say recovered and then reflect the amount of people for that recovery data set. For deaths, we want that to be very similar to the way for confirmations and recovered. For extra help using Leaflet, please click on the website on the website link, hypertext link provided in the web question prompt. This website will provide you all the details necessary to complete this assignment. It is recommended to use Leaflet. For the third objective, we want to narrow down hotspots. Because we're using R Markdown to create HTML files, we have much more options for how we display our tables. For this table, we want to rank the countries by on a 1 to whatever rank, showing the confirmations, recoveries, and deaths with the top countries respective for those different data sets. For this data table, we want to have a custom title. We want to have custom labels, and we want it to be able to be somewhat interactive in a way because we are using an HTML file. You can see here that this one is scrollable. While it's not necessary to exactly reflect this data table, it would be a great challenge to try to replicate it to show off your knitr prowess. For more help customizing tables using knitr, please click on the hypertext link provided on this website. It will give you everything you need to know to create this data file, this data table exactly as shown. For the next objective, we want to zoom into our state. For this, we want to provide scatter plots of California, both the total trajectory of California for COVID-19 for confirmed deaths, as well as the top confirmed cities. That is confirmations for the top confirmed cities listed in California. We also want to provide a dotted line here that shows when the shutdown occurred, which was March 19th, 2020. For each of these, it's recommended to use CalPlot to organize the graphs so that we can have the plots plotted using plot grid, plotted one on top of another, as shown below. We want to include custom axis labels for each of the graphs, cases in this hand, date on the other hand. We also want to include custom titles, and we want to include custom legend labels. For the next question, digging deeper. Although these plots do not tell the whole story, they are a great deal for helping us determine where to look. Different cities may have different populations, population densities, cultural discrepancies, compliance, and city regulations, to name a few. We'll explore the role of population on these metrics using visualizations. For this objective, arrange two scatter plots using CalPlot's plot grid to show the relationship between population and confirmed counts, as well as death counts and confirmed counts. You will need to use a log transform on all variables to show such a relationship. For the log transform shown in these visualizations, I used a log2 transformation. Any log transform will do, however. Please consult the example below for an idea of what this may look like. From these graphs, we can see populations greatly affects confirmation and deaths. This coincides with our plots above, as Los Angeles population is 300% greater than San Diego's population and 400% greater than Riverside's population. When you're constructing these visualizations, you may notice that you have many different data values that are horizontally and vertically oriented on the outside extreme parts of the axes. This is due to the fact that the log of 0 is negative infinity and the log of 1 is 0. If you would like to remove these, as it doesn't really contribute to the patterns displayed in the visualizations from these graphs, please filter your data sets to be greater for data points that are greater than 1, at the very least. For these ones that I constructed, I filtered data sets for data points that are greater than 10, both in terms of confirmations and deaths, and in terms of confirmations and population. If you need any help on the project or any help making these visualizations, please don't hesitate to ask. Also, if you have any questions regarding the project itself, please contact me. I'm available for Zoom, email, text, or call. Thank you very much and enjoy your week of learning.